Hi students, we will just continue with our examples. This is called as a 4-point tent, and then two moving coil with the meters, that is called as a M1 and M2. Two meters are named as M1 and M2. Their resistances and number of turns, area, then magnetic fields for both meters has been mentioned to us. So first of all, we have to find it out that the current sensitivity and voltage sensitivity of both meters. So first of all, what I am doing is that current sensitivity. So for that I am just using this formula, phi upon I is equals to, my equation is called as NAB by K. So what I am doing is that for the first one, that is called as a phi upon I, by for the first one N1 A1 B1 by K1, this is my first one, and for the 5 by I of second one is equals to N2 A2 B2 divided by K2. This is my equation number 1. But they have mentioned that the spring constants for the both the identical part, you can say that number of turns, area, magnetic field, K is called as our springs sensitivities, are equal. So I am just using this part, K1 and K2 both are equal. So I am taking that ratio of equation number 2 is to 1. So my formula will be look like 5 by 8 of a second one divided by 5 by 8 upon first one, that is called as N2 A2 B2 multiply by K1, and I have N1 A1 B1, and that is called as a K2, but both are equal because of this one. Now I am putting that value, I am just mentioning this number 5 by I of a 2 as a 5 2 dash, and this one 5 by I of a 1 is called as a 5 1 dash. So I'm just naming it as a 5 2 dash, and this is called as a 5 1 dash. Now I'm placing their values. So it would be 4.42, sorry, it is 42, then we have a 0.5, then it would be 1.8, and 10 to the power minus 3 divided by number of returns. For the first one is a 30, my area is called as a 0.25, and magnetic field for the first one is a 3.6 cross 10 to the power minus 3. 10 to the power can be cancelled out directly, so I can have a 5 2 dash by 5 1 dash is equals to that would be 1.4. So this is the value I have received. I am naming it as a dash. This is called as a sensitivity of my ammeter. This is the first thing we have find it out, current sensitivity. Now I want to find it out voltage sensitivity. So you are aware that the equation of a voltage sensitivity, it's a having relationship that is called as a phi upon V is equals to NAB by KR. So you can just say that 5 divided by V, and 5 divided by V of this second one, I am just mentioning this one, and 5 by V of the first one. So I can just directly place its values, that would be N2 A2 B2, and then is called as N1 A1 B1. I have here K1 R1, I have K2 R2. You can see that K1 and K2 can be cancelled out because of their values, because it has been mentioned that both are equal. So both are equal, K1 and K2. So I am using those data. I am also using that previous data N2 A2 B2, and N1 A1 B1 is called as a phi 2 by phi 1. So this entirely I have data available to me. So I'm just using this data. So from the A, N2 A2 B2 N1 A1 B1 is already calculated, that is called as a 1.4. Resistance of the first one is called as a 10, and resistance of a second one is called as a 14. So I can get the ratio is 1. So my ratio of 5 by V of 2 is to 1. So my ratio would be only 1. So this is the data they have asked us. So very simple example, but sometimes in the school or board exams they are asking for the 3 marks as well. Not because of that's a complexity, only because of the content which you have learnt in the theorem part. Now you have example number 4.11, where you have been given a chamber, and into that you have to just find it out. It's a magnetic field, what amount of current it is containing. Let's see whatever data has been given to us. In the chamber of a uniform magnetic field, then we have a first of all magnetic field is a 6.5 Gauss. You are aware that Gauss equals to 10 to the power minus 4. They have just given you, we have already discussed in the initial part of this chapter. We have our electron or charge, which is moving with a velocity 4.8 cross 10 to the power 6 meter per second, and it's a path. We have to just say that it is why it is following circular path. You are aware about its journey, why it is called as a circular. So you are following that theory of a cyclotron, which is saying that it's a path. So there is no need to discuss over here, but you have learned that theory. You have been mentioned that a charge of electron, whether it has been not mentioned, you are also aware about its value. So that is called as a 1.6 cross 10 to the power minus 19 coulomb, and mass of electron is 9.1 cross 10 to the power minus 35 kilograms. So you have directly our data is available to you, mv, and that is called as qb sine theta. Or you can just say that instead of theta would be 90, I can have r is equals to mv divided by qb. People are asking that why and how this expression we have received. So you are aware about that equation of Lorentz force. So that was called as F equals to qvb sine theta, and we have a centripetal force, that is called as F is equals to mv square by r. You can now compare both equation number 1 and 2, and then you can directly have those data which is in the terms of our radiuses and velocity and the form you want. So I'm just doing all those data for you. So my formula is ready in front of me. So my values, I'm putting that radius r equals to my mass is 9.1 cross 10 to the power minus 31 multiply by 4.8 cross 10 to the power 6 divide by 1.6 cross 10 to the power minus 19 multiply by 6.5 cross 10 to the power minus 4. You can first of all just go with the power and calculate the power, then you can have all those data available to us. So I am just using that my radius r will be 4.2 cross 10 to the power minus 2 meters, but your data is in terms of a meter. I can also say that power is 10 to the power minus 2, that is why 4.2 centimeters. So this is the thing you can conclude about our example number 4.11, which is dealing with the theorems of our cyclotron. Now we have exercise example number 4.12, which has been mentioned that where we have very first one thing we have to see that our relationship with the force and velocity is dependent or not, that we have to just show them. Answer dependent on the speed and electron, and it is called as a frequency, and we have to find it out frequency of revolution. It means that we have to find it out frequency. So I'm using the same notation. My equation I'm just using is that mv square by r is equals to qvb. Now you can see that my both this side contains v, so v can be cancelled out. So I can have my value that is called as mv by r is equals to qb. But in 11th science you may have learned that v is equals to r omega. This is the relationship between the linear and angular velocities, but omega equals to 2 pi f. So I can just say that v is equals to 2 pi rf. So this is the data available to me. I'm putting all those data in the above expression, and that is called as a 2 pi rf divided by r is equals to qb. So you can just say that my equation of a frequency is a qb divided by 2 pi m. You can say that there is no relationship dealing with the velocity, so you can say that f and v are not correlated. So my velocity and my frequency having no relationship. So I'm putting all those data. Value of a q means electron, 1.6 cross 10 to the power minus 19. Magnetic field I have, that is called as 6.5 cross 10 to the power minus 4. 2 multiplied by 3.14, and then mass of the electron is a 9.1 cross 10 to the power minus 31 kilogram. So my frequency I will receive is called as a 1.82 cross 10 to the power 6 hertz, or you can say that it is 1.82 megahertz. So this is how it has been derived. So from this one you can say that our frequency is having no relationship with our velocity. So this is how you can be calculating 1.82. Next one is called as our circular coil. Data available to us is that our circular coil we have, which is having 30 turns, which is having radius is 8 centimeter and carrying a current of a 6 ampere, and magnetic field of a magnitude is called as a 1 Tesla. But they have used that circular word and making an angle of a theta. You are aware that whenever such type of a torque we have to find it out. So first of all, I'm using all those my data of my magnetic field and area and whichever thing they have mentioned to me. Magnetic field is a 1 Tesla. They have mentioned the radius, that is called as a 8 centimeter. I am using that data, that is called as my area, is called as a pi r square. So my area would be 3.14 and 0.08 square. So I can have my area would be 0.0201 meter square. My area is available to me. My theta and current, my current is has been mentioned to me is called as a 6.0 ampere, means 6 amperes. Theta has been mentioned to me is called as a 60 degree, and my number of turns they have mentioned, that is called as a 30. So all data is in front of me. So I am using all those data and finding it out that tau is equals to beta sine theta, or you can just say that I don't have n by l, that is called as n by l is equals to small n. So directly I have mentioned this thing. So I am using that tau is equals to bi small n a sine theta. I am putting all those values, 30 multiplied by 6, 1, 0.0201 and root 3 by 2. So I may have 3.133 Newton into meter, or you can use that data, that is called as a torque, is called as a joule. Now they have asked us another question, that would your answer change if circular coil were replaced by planar coil of some irregular shape? You can see over here that there are various type of equations or relationship we can make. So very first thing we can make is that our tau is having relationship with the magnetic field, tau is having relationship with the area, tau is with the number of turns, or tau is having relationship with the current. I am using this word, they have area relationship, not of a shape. So you can say that torque, which is depends on area, it is not dependent on shape. So it is not dependent on a shape. It might be of a circular, it might be of a triangular. So your area will change as per your answer will change. So it depends on the area, not depend on the shape. So your answer will remain as it is, even though it is of a some irregular shape. Okay, so these are the things where you have been also mentioned that all the other particulars are also unaltered, means unchanged. So without changing all those things, your answer will be same. Your area is not supposed to be changed, because it is not mentioned that, it is shown that it depends on the irregular shape. But we have proved that already. Tau is having relationship with all those four quantities. It has nothing to do with the shape. So you are quite comfortable with the such type of formulas. In the next clip we will discuss about some of the extra exercise examples. Thank you.